Here we are in beautiful Wisconsin, USA, just outside of Green Bay. With us today, we've got Rick and Matt from Components Plus out of Columbus, Wisconsin, and I'm Adrian from EI Engineering from Australia. And Rick has hired an operator for today with over 30 years experience to carry out this test. With EI Engineering's success in bucket wars back home in Australia, we thought we'd bring it to the USA and see how we go against the Americans. Welcome to Bucket Wars. What are we doing today, Rick?
Well, today we'll be digging some trenches here on our family farm just north of Green Bay and testing out these buckets. When I met Adrian at the Con Expo this spring, he showed me a design of a bucket that's more efficient, produces less drag, and can save fuel costs and increase the operator's digging power. So I invited him up here to Wisconsin, and we're going to be testing out these buckets. So we'll be digging two trenches side by side in the same soil, measuring the fuel and measuring how much we can actually dig out of a trench. The trenches should be about 6.5 feet deep. And we're going to see how far they go, and then we'll measure the fuel used on each bucket and produce these results. We have the 24-inch bucket on an 8-ton machine. It's a CAT 308, and judging how much we can get through it and then how much fuel consumption we use on each bucket. The machine will be filled up as we start, and then we'll measure how much fuel we put in to bring it back to the full mark. These tests will go for about a half an hour, and then we'll measure the machine and come up with a percentage of what we are saving with the fuel and how much further each bucket would dig.
And after we're done digging, with the measurements we have on fuel and how far we dug and how deep, and we'll calculate that all out to see what the difference is in the two different products.
As you'll see in the test, the material we were digging was quite sandy and moist places. Both buckets experienced fairly easy digging. The locally built bucket dug 87 feet at an average depth of 69.2 inches. Works out to be 37.16 cubic yards and used just over 1.5 gallons of fuel. We then tested the EI Engineering bucket, and the trench was 100 feet at a depth of 70.2 inches, which worked out to be 43.3 cubic yards, and used just over 1 gallon of gas. So the winner of today's test is the EI Engineering bucket that dug 15% more at the same time and used up to 35% less fuel. So the results of the test show that use of the EI Engineering bucket, you will save 15% in your operating cost, 15% in service, repair parts cost, and 35% fuel cost. In harder ground, we expect bigger variations. So for your next test, we'll find some clay and harder soil.
If you're a machine dealer or an OEM, of course you want machines to provide the best power and performance so that your contractors keep coming back for more machines when building or replacing their fleets. And if you're a contractor, of course, you want to see the great savings you can get on current machines or how you can grow your business and earn the most money through greater productivity. So this is not a digging race, this is a war of design and construction. And the challenge is to supply the contractors out there with buckets that dig better and make them more money.
So, there you have it. The results are in. We've won the first round. Let's see what happens in the fall when we come back and do another test in some harder ground. So, thanks Rick and Matt. It's been an absolute pleasure, and thanks for putting us up here. It's just a wonderful place. Really appreciated it.
Well, we appreciate you coming and giving us an opportunity to look at this design and compare it to what we currently use, because we want to make your machine work better, more efficiently, more money for you to keep in your pocket.
Yeah, absolutely.